Hello, everybody. Digital media editor Warren Frey here, and I'm here on a special podcast about wood construction with...
I'm John Hemsworth, principal of Hemsworth Architecture based here in Vancouver.
And Robert Malczyk. I'm a principal with Equilibrium Consulting, Katerra in Vancouver.
And we're going to be talking about a couple different projects today. The first one is On 5, which is named, I believe, because it's on the sort of the corner of Ontario and 5th, or in that general area in the Mount Pleasant neighbourhood in Vancouver, where I'm located as well. I'd like to ask, first of all, because I looked at a bunch of literature about it, and it looks like a very impressive project with a lot of interesting techniques. I couldn't tell if it's an office or residential or what the function of the actual building is for. So maybe we could start with that and go from there.
Yeah, so the city is, John, the city is looking at kind of densifying this whole area. And so it was an industrial area, a light industrial area for a long time. And so what they've done is they've put a kind of a new zoning on top of it where you can add double the area of office above the industrial use on the ground floor. The interpretation of industrial use is like a little fluid, I would think, within the city. Their intention is like to keep some sort of light manufacturing in that area. So what the buildings then kind of program is a ground floor, which is actually a double height space, again, derived from the city's zoning for a light industrial use, which, is still to be determined. Or Robert could speak to that as the owner more directly. And then 2 floors and a little, so it's not quite 2 floors, a little bit more than 2 floors of office space above. And that came from manipulating the FSR 3 based on over insulation of the walls for passive and a bunch of things. So we ended up with a bit of extra area, which we pushed to the top floor. So it should be a 3-story building. It's 3+ story building.
And it looks like, from what I can tell, is it's a real showcase for wood design. So there's a lot to go into. From what I can tell, CLT and passive house. Maybe you could sort of go into the highlights of what the sort of predominant wood features are of the building.
Well, I'll start and then let Robert take over. Robert is a structural engineer of some note, who I'm sure some of your listeners might know of. And so Robert and I have worked together on a number of projects. One of them we're going to speak about at the second half of this, which is the Upper Skeena Rec Centre. In this project, Robert is also the developer / owner of the building. So it gave him an opportunity to play out some of his kind of more, I don't know, what's the word for it, aggressive or opportunistic structural kind of solutions in the building, which we wouldn't normally do in a kind of regular build per se, where it's... So this building, again, is a kind of showcase of mostly Robert's skills and abilities. There was some kind of limiting factors in all of this. I mean, ideally, we would have liked to have done the whole building out of wood, but the city's interpretation of that industrial space is that it's a light industrial space, which means an F2 in the code, which came to be a bit of a difficulty kind of getting it through from a code point of view. What we have done on this building and other buildings is, instead of building a concrete or block wall at the 0 lot line to separate the properties, we're using a mass timber wall with exterior insulation, which gets us to the passive insulation level, but also works from a structural point of view for Robert, but it replaces the standard kind of concrete block wall that you would see in most of these 0 lot lines. So we've done this on a couple of projects. It takes a kind of special type of approach with it, but then it gives you a building that you can expose the mass timber. You can use it as a structural element, and it also gets you much further along from a passive point of view, because we're pre-insulating those panels and then sliding them into place, versus trying to put a concrete wall there, and then there's no way really to insulate it from the outside from a passive requirement. So from our point of view, that's the kind of innovation part of it. I can let Robert talk more about the structural kind of approach that he's taken across the project.
Sure, please do, Robert.
So first of all, I just want to say that as consultants, John and I, we worked over a very long time together, and we were able to form a team with creative energy that comes into our solutions. As a person, I believe that each of us has to do something for the environment, and I myself bike to work and I live in passive house, and I think that as consultants, as people in the timber industry, we have to lead the way and we have to set an example. So the purpose of this building is not only to live in a passive house, but also work in a passive house surrounded by wood. And I keep on planning biking back and forth my residence to these buildings, not to pretty much to use all the active transportation. So regarding engineering innovation, there's quite a lot. So first of all, the passive house panels that John mentioned, they're also shear walls. But they're not only shear walls, they're also providing for vertical load support. So this is the first time ever in British Columbia that I'm aware of. The building on a zero load has vertical panels that support the load, support the live loads and the dead loads, of course. Mm-hmm. They are also a firewall, so they're calculated for charring, and they're also shear walls, so they are providing the lateral load resistance. And on top of it, they're fully prefabricated, so they will come like the big chunks of vertical walls together with the insulation, with the finishes, with the rain screen, and they will be connected from the inside with the splines that will have connections. And John came up with a system how to work it for the envelope and to make it watertight and safe. So this is number one. Number two is that I always wanted to as a structural engineer, to sit in a building that will self-center itself after an earthquake. So as you know, as structural engineers, we're really passionate about earthquake resistance, and we always looked at the load paths and how buildings behave before, during, after an earthquake. So typically an earthquake moves back sideways, and then a lot of times you have to demolish the building. Like in Christchurch, almost 10,000 buildings have been demolished. The building here, because of the system of hold downs developed by Pierre Canville, a Canadian who is now teaching in Auckland, New Zealand. So the system is a self-centering hold down. So after the earthquake will be, the building will be moved to one side or another, and then the hold down system will move it back into the so it will be able to have immediate occupancy. That's what all of us engineers, that's our buzzword. We want the buildings to be immediately able to be occupied after an earthquake. So really passionate about this one. And the third one, this is called TS3. It's a flat slab seal system. This was developed by my other friend, Stefan Züllig from Switzerland, over many years, and it was a dream to create CLT buildings that do not require beams. So in On5, no beams. It's pretty much all slabs and all walls and roofs. So what the TS3 system does, it creates a full moment and shear connection between CLT panels that are connected sideways, and it doesn't require the beams. So if in a typical concrete building, we would have a grid of concrete columns 30 feet by 30 feet, and before this system, we could never have a flat slab. Now we can have a flat slab out of CLT, which is great for the looks and also for mechanical coordination, and we can compete head-to-head with concrete with this system. So all of this together with prefabrication, it's kind of, as John said, I had the chance to really work on these, and it was wonderful also to be selected as a pilot project by NRCan through a very rigorous process of showing the innovation and to get help from the government to showcase all of these technologies.
Mm-hmm. That's a lot to take in, but it sounds like with seismic, at least, you've that would be my main, and I'm a layman here, but as my main concern would be that wood would be less resistant to seismic problems than say concrete would. But it seems like in this case you solved that problem.
No.
No, it's not even that. Yeah, like I mean,
Go ahead, John.
Well, it's one of these things, like it's these preconceived ideas. Like when you think about it, so for any building, we're in Vancouver, so we're in a high seismic zone. So if you think about it just abstractly for a second, the heavier their building is, the bigger the forces are. right? So you build a big building out of concrete, and then you're like, okay, well, concrete doesn't take tension, so I need to put more steel in it. And now the building's heavier, so then I got to make it bigger. It's this kind of Cold War of kind of construction methodologies. Whereas wood construction is significantly lighter, it's more flexible. And so what actually happens is you get a better performing building. That's why the stick frame houses do well and the bigger buildings don't, right? And so that this methodology isn't just like for Robert to have solved, like Robert's talking about very kind of innovative approaches to dealing with the seismic so that the building is actually usable after the earthquake. Okay. This is just simply like compared to concrete buildings. This is light years better to be building out of wood in this environment than it is to be building out of concrete. I don't think I'm overstating that, Robert. Like, that's fair, right?
Yeah, but John, this is more to that, because energy efficiency is all about energy dissipation. All about taking this energy gracefully into the building and transferring it down to the foundations. So buildings like on 5 have been designed according to the principles of capacity design. Capacity design is a method where you identify parts of the building that take all this energy and that dissipate it. Everything else is over-designed. It's like a link with all the parts out of steel and one of the parts out of rubber. And this rubber stretches, but it doesn't let go. It just dissipates energy. In our case, it will be the tectonus hold-down system that will dissipate this energy. So this is new concept originally developed in New Zealand for high seismic regions. And wood is absolutely perfect, as John said, 1/6 of the weight. So in comparison to concrete. And the other thing, it's so much easier to make the building back into vertical when you have a lighter building. In concrete, it would be much harder.
Mm-hmm. And I assume since it's pre-manufactured, it's also, if there is damage, it's easier to fix it again if you had to.
Exactly, but we are not assuming a major damage here.
Right.
We're assuming that the building will behave in a ductile manner.
Now, given all the innovation you guys put in this building, what were the challenges behind that, or was it actually easier to build it this way?
Oh, the challenges were many. You start, John.
Well, I'll say this. I mean, we're pretty invested in sustainable design and been working from a number of projects that are kind of biased by this approach that we need to, do more than what the standards of practice are. And so we worked a lot in passive house and almost exclusively now in mass timber projects, just because we think it's the place to start. So those, from an architectural point of view, you can look at the work, you compare it, like there's the work holds up, not just ours, but anybody working in this medium. From a structural point of view, there's advances that Robert and his groups are making as well. The real challenge for all this is simply, and not to throw anybody under the bus, it's the authorities having jurisdiction. It's them coming to terms with the fact that this is a viable solution, that this is something like, we've done 2 projects now. We're doing mass timber infill right on 0 lot lines in an urban setting. There's a whole bunch of reasons for wanting to do that, but and it's not necessarily the code issues here, because the code, there's ways to, we understand the code, obviously, and we understand working with different code consultants of looking for alternate solutions where we believe it's, it's in keeping with the code. Ultimately, where the struggle comes is that each municipality has their own bias or lack of bias towards these projects. So each municipality, so if you do one project like we're doing in Vancouver, and then you do cross the water and do another project in North Van, the responses from the authorities are completely different and unpredictable in some senses. And that's the ultimate challenge for these projects, is that there isn't enough consistency. And when you start using things like, okay, we're going to do a 0 lot line. So now, based on the code, it has to be a non-combustible wall, but we can build it out of wood. We can show that it works. We can show that it's not a risk. We can show that it meets the fire resistance. We can do all that stuff. All that information is available. But for each project, you have to go and reprove that to each municipality, and ultimately to each building inspector or chief building inspector. So that process in itself is flawed. Like, ultimately, if someone's showing you, we've done this project in one place, then, and the problem is it's just a bureaucratic kind of backlog of trying to get people to that point. Generally speaking, at a high level, the city of Vancouver, has a strong commitment to sustainability and to kind of building a green environment. But when it gets down to the kind of base level of getting things approved and getting things to move forward, it almost turns into a kind of personal discussion or individual discussion versus a systematic discussion. And so with each one of these projects that we're working on, there is always a challenge of being at the kind of leading edge of this stuff because people are like, I'm not sure. And it's like, well, there's a lot of things. So we have to go through and prove all that, which is fair too, to the same point. Like people shouldn't just be taking our word for it. But because it's specific responses by specific individuals, you can literally have the same building. Like you could have one in Vancouver and one across the line in Burnaby and have two completely different responses from an approvals point of view with the same building. And that is the ultimate challenge for all these things for us. So you can look at one building and say, oh, we should do that. We should do this in our city, town, community. True, you should. But then the ultimate first discussion is with the architect or the project leads and the authorities having jurisdiction to see if there's an appetite and understanding. Some places are much more flexible in dealing with that than others. And I don't have a chart or graph across the province of which ones are good and bad, but you basically have to sit down at the beginning of them. And that is ultimately the challenge with these progressive projects, is that they have to become systematic in their approval, not kind of one-offs. So, and I could go on and on about that, but from another point of view, there's just the average challenges of working in a large city and the kind of the slow time for responses, the amount of time it takes to get feedback from building permits and zoning and all that stuff, which is endemic, and everybody is facing the same issue there. So I don't think that has anything to do with these type of projects, but there is a special type of lens that the city should be looking through when it comes to these type of innovative projects, which at this point doesn't seem to happen. I think there's a desire for it to happen at, like I said, a high level, but when it comes down to the kind of in the trenches, you're gonna have to fight your way through.
I just want to add to this that it's easier for John and myself to work on these projects because we are in this industry for so long. Right. We had to submit the whole bunch of latest fire testing reports, working together with our code consultant Jeff Triggs, and we had to show the latest methods, the pushover analysis, the nonlinear dynamic analysis, to use these new systems. So it's easier when you're in the know. Like I sit on all these code committees and on CLT and on wood design code committee. So it's easier this way. But the plan for our project is to publish it all. We are getting great help from FII and from NRCan, and we're preparing publishing information on it. We have the representatives taking information from our design meetings and pretty much trying to help, because this is such a typical lot. We have so many 25, 33, 50 lots, middle lots in the city of Vancouver. And in our province, all these buildings really have a potential to use cross-laminated timber and glulam and the latest technologies. So that's an example. That's the whole, to show the way how this can be done for the typical client, the typical developer. So that's the goal here.
Okay. And moving on to the Upper Skeena Recreation Centre. Again, I'm a layman. You guys can tell me if I'm wrong on this, but it seems like a very different project in terms of volume and in terms of what you've got to deal with, like materials and the fact that it's a cold temperature environment, both inside and outside. But explain to me what that was like building that project.
Well, that one started out from a different trajectory completely. Like Robert and I were working years ago on this idea that you could, because I mean, to back up for a second, most of this infrastructure across the country is coming to the end of its lifespan. The arenas, the ice rinks, all that kind of stuff. So there was a request by BC Wood to put together a prototypical arena, because generally they're built out of kind of steel frame buildings, and people say, oh, I'm a small community, I need to replace my arena. They go online, find a steel frame building, and they think that's the cost of it, but it's not, because there's no foundations, there's no ice plant, there's no insulation, there's no seating, there's no washrooms. So BC Wood asked us, and with Robert, obviously, to come up with a kind of prototypical scheme of how you could build these buildings roughly at the same cost of doing them in wood. The problem is, because it's a long span wood structure, you can't kind of get halfway through the steel design and then flip it into wood. So we spent some time early on looking at how to make a cost-effective long span glulam structure. And that's a long story of how we got there. It's quite a brilliant solution in the end, because the building works as more of an arch, and then it works as a kind of a single span. Spliced to there's actually 3 beams across the top, 2 of them being cantilevered and the third one being dropped in, 0 moment at the splice point. So there's a whole bunch of ways of controlling the span. And then what we did is we put it together as a report, and it was released, I don't know, years ago. And by some fluke of the world, we had picked a small town, Hazelton in central BC, just to do the snow loading on the report. A year and a half later, we get a call from that town, who's a prominent doctor, Dr. Newberry, who's kind of putting together an approach of replacing his arena because of the social and economic issues in that part of the world, how to kind of build a locally based arena. So we didn't know he was looking to replace his arena. We just kind of picked New Hazelton as a place to get the snow loading. So what happened was the whole project leaped forward, because now the schematic design was done. The structural system that Robert developed worked. And then we just basically added a gymnasium and a community room to the design of it. So it started out as a desktop project that I don't think anybody thought was actually going to be built. And now it's been finished. It's been, I mean, it's fairly well published at this point. We're very, very impressed and thrilled with having been involved in it. But mostly it's about the kind of capacity that it built within the community, and the ability for that community, small community, to kind of marshal its forces and the people around it and build it. And one of the things that we did in the design was to panelize the wall and the roof panels, meaning just use standard lumber, all the insulations on the outside again. What this did is it created an opportunity for people to actually be able to work locally on the job. So instead of everything being shipped to these communities, we could put together a workforce using local labor to build those panels. And I believe the number is around 3,300 man days were done locally in this small community, which really kind of made the project not just economically viable, but socially viable too, for a part of the world that struggles from an economic and a social point of view. So it's kind of winning on a whole bunch of different fronts for us on that project. Besides it, I think it's fair to say that it's stunning. It looks great. Like, it's a really cool building, which is kind of a nice byproduct in these things.
I just want to add, from the structural point of view, as John said, that the whole building was designed in a simple way, and using local materials, using wood framing as much as we can, regular wood framing ideas from typical residential construction. Added is these glulam beams that also came from a local supplier, and they are the ones in a way that we use the V's and the tension and compression elements out of them to decrease the span. So the structural idea is pretty much to cantilever from 2 sides and then infill the center of it. So kind of like a typical Gerber design with some moment fixity. And in the end, it proved so efficient, and it proved efficient, and it was able to achieve as much local participation as the original arena that we had a great story, John. So when we first came to this site, there were kids in the old arena, and we started looking at the wood. And I realized, being a timber engineer, that it was dangerous, that there was so much mold and so much over the years that we went straight into the RCMP, and on the same day we closed the arena. And it was a shock for the community, and And in the end, we got a nice, letters back saying thank you for saving the kids. And thank you for preventing, something that could have been tragic. And still designing a new building with the local materials and built with as much participation as possible. So that's like the personal, John, right? That's kind of what is the biggest thing for us.
It's a pretty remarkable story. I mean, that old building was basically an A-frame that was built by volunteers. The logs weren't skinned, they're about 60 feet long. They put 2x infill material and just put tin on the top of it. So there was no lateral design in it. There was really no thermal environment, like there was no envelope, there was no mechanical system. There was basically just an ice plant. And that building stood there for 42 years and became a big part of that community. So when that building came to the end of its lifespan, this became the kind of regeneration. The project has been called the Heart of the Hazeltons by the local community because it plays that much of a role in the health and the well-being of the environment. So it's very humbling to be involved in a project like that because I feel quite strongly that it has offered a whole bunch of opportunities both for people in the design and the construction, but also for the everyday use of it that would not have been there if that opportunity hadn't arisen. So it's a very compelling piece of work for us. And as always, we're looking for ways to be environmentally sensitive to the work, but also there's a kind of social sensitivity in the work that has to be there as well too. Because if you don't make buildings that people care about, then no one's going to use them, and then they fall apart. And that's kind of a bigger metric in kind of sustainability than how many tons of carbon are sequestered in the construction, which is important, but it's hard to kind of measure that in real world terms. Whereas you walk into this building, it's full of laughter. You can see people there. We were there last year before COVID, and it was a Friday night, and the building was full of kids and their families skating around in an environment that doesn't have that opportunity. Like there's 15 different things to do there on a Friday night. So it's a very satisfying project for sure.
I just want to add also that, what John, what you were always saying is that you always wanted to create beautiful buildings for regular communities. And this is an example of that. A simple, efficient building with a beautiful architecture that has an effect of people. Like people love the building, people love going there. And that's how it should be, that it has an impact on everyday life of the community.
That's it. Robert, you're being well trained now.
No, I should be an architect now, and you should be an engineer.
We'll switch for the next project and see what happens.
Just to wrap up, I was going to ask, and I think I have a good idea given what you guys have already said, but what do you see as the future of wood in BC? It seems like you want better, not less, but better regulations, sort of province-wide, and different uses than we've come before, like this arena, for instance. But don't let me put words in your mouth. What do you guys think?
Well, I'll let Robert close out, but from my end of it is that I grew up in the Maritimes on the East Coast and moved out here after I finished. Robert's alluding, I have an engineering degree as well, though it's unpracticed. But when I came out here and went to architecture school, I was just floored by, honestly, the scale of the trees. Like, it's really something that if you're not growing up here, you kind of maybe lose. I mean, maybe if you grow up here, you kind of lose perspective on it. But from my point of view, it's always been something. And then the more research I did as I became more invested in the kind of wood industry here, is that we're not really inventing anything here. This is the way this part of the world was built. It was built using large pieces of wood. And obviously, the engineering has changed in that. Now we've gone to engineered wood. But the idea that, where is it going is I think we're just trying to get back to where we started, which is it's the first response. Like, you should be building buildings out of wood, full stop, right? And then there's points where, okay, now we need steel, of course, now we need foundations, so we need concrete. That's always, these are the responses that you need. And you're not going to build glass windows and stuff or wood windows. So there's a certain point where you're trying to do it, but your first part of first response for all of these buildings, be it an arena or a zero lot line infill building or a school or, any number of things. And we're, as a community here in BC, we're kind of leading the charge on that, across North America. And that's where I think we need to get to, is back to the place where this is how you start. And there's all reasons, like other metrics, to go there. But from that point of view, I think that's the path that we're on, and we don't seem to be alone in that. Like, we seem to be, it's fairly, well trodden path at this part. And to Robert's point, what we're trying to do is make our buildings just not just be based on the fact that they're wood and that's enough, but they need to be beautiful. They need to be economic. They need to have a play of light in them. They need to be places where people want to be. And that, to me, is true sustainable design. So I'll let you, Robert, you've got.
I just want to add that on the side of regulations, and I'm working with the engineering community and the province on that, BC is a leader in mass timber. We as much as I know, we're the only province that has the government representative for pushing mass timber, and it's absolutely wonderful. And the other thing is that right now, wood is really going mainstream, and this was always part of my personal goal. I came here 30 years ago to study at UBC, and I spent all my working life here in Vancouver. So there is so much interest right now from private projects, from public buildings. We really created a cluster of excellence here in BC among the architects, engineers, code consultants, fabricators. We really have a cluster of excellence that it's unique in North America. We are actually a powerhouse, and we're considered the most advanced area in North America in mass timber. So that's really great for our economy and for our, and I think it will only grow faster and faster.
All right, that's as good a place to leave off as any, I think. Thanks, guys.
All right.
Thank you.